Hi, my name is Devoshpire, and today I will be talking about Eliquis. Now, Eliquis is a drug used in medicine, and it is usually consumed as part of a solution. So today we're going to try and test out three possible candidates, which of those candidates would be the best solvent for Eliquis. So our candidates are water, hexane, and dimethyl sulfoxide. So first, what do we know about Eliquis? Eliquis is an organic compound, and its molecule um, has a polar end. So here we're having an example of a polar compound. So we're trying to find a polar substance to be the solvent. So if we look at hexane, what do we know? Now remember, in organic chemistry, in each one of those vertex points, we have a carbon, a total of 6 carbons, hence the name hexane. Hex means 6, is overall nonpolar. So remember, we said we need two polar substances to be solvent and solute. So hexane would not be a good candidate. So let's look at water. We know that water is polar, but if you think about it for a second, water is polar, but it's not an organic compound. So that what that means is that water could be a possible candidate, but it's not ideal. And the reason for that is that it would only dissolve the polar ends of that molecule. And we have this entire um, chain of organic compound that water cannot really interact with. So water is a possible solvent, but it's not ideal because we don't get a good solution where Eliquis is completely dissolved. Now, dimethyl sulfoxide has this resonance structure, which means that it has two possible structures, but in reality, the actual structure that we see is a hybrid of the two. The shape is trigonal pyramidal, which tells us that the molecule has a dipole moment, which makes it polar and therefore a good candidate to be the solvent. And the other thing that dimethyl sulfoxide has that water doesn't is that organic component to it, which is a 2-methyl group. Now, the actual structure, what we have here is a hybridization scheme of sp2p, and that sp2 is in charge of the 3 sigma bonds that we see, 1, 2, 3, and then the other p is in charge of that pi bond, which is part of that double bond. Now, why do we see a single bond? The reason is that the p orbitals that participate in the double bond and sulfur atom are the 3p orbitals, while oxygen's p orbitals that participate in that bond are from the 2p. That distance make them only tangent to one another, so that we don't get a full overlap as we would if there were both the 2p. Therefore, it's only like a scattering double bond, and it's actually more of a single bond that it's slightly more enhanced and stronger and kind of has some of that nature of double bond, but it's in reality a single bond. So that's it. We talked about the best candidate for our Eliquis is dimethyl sulfoxide, and we talked about the resonance structure of dimethyl sulfoxide as well. Thank you.